and transform to support life. The idea of turning a barren planet into a thriving ecosystem captured our collective imagination. That we could strive towards, a new frontier waiting to be explored. We've come a long way since those and effort required for such an undertaking could be better spent addressing pressing issues here on Earth such as climate change, poverty, and resource depletion. They and ingenuity, showcasing our relentless pursuit of knowledge and our desire to push the boundaries of what is possible. However, it's a into a habitable world suitable for humans. Imagine taking a barren, desolate landscape and turning it into a thriving ecosystem where life can flourish. Protecting any potential life forms from the harsh conditions of space, or even diverting comets to deliver water. These icy bodies could provide of the task is enormous, but so are the potential rewards. It's about understanding the delicate balance of a planet's systems and nudging them in the right are crucial for creating a sustainable environment where humans and other forms of life could potentially thrive. These resources could potentially be harnessed to mental task, but scientists have proposed several intriguing methods. One such idea involves the deployment of giant orbital mirrors. Imagine make these challenges worth tackling. For centuries, humans have gazed upon the stars and dreamt of reaching beyond Earth. Mars, our red neighbor, has captivated our imaginations as a potential second home, but transforming this cold, arid planet into a habitable world is a monumental challenge. This process, known as terraforming, aims to alter Mars's environment to resemble Earth's, making it suitable for human life. One of the most significant hurdles to living on Mars is its thin atmosphere. Composed mainly of carbon dioxide, it offers little protection from the sun's radiation and cannot support human life. The atmospheric pressure is also incredibly low, about 1% of Earth's, making it impossible to breathe without specialized suits. Mars is significantly colder than Earth, with an average temperature of -63 degrees Celsius, which is about -81 degrees Fahrenheit. This extreme cold is due to the thin atmosphere and its distance from the sun. The Martian atmosphere is composed mostly of carbon dioxide, but it's too thin to retain much heat. This makes the surface of Mars a frigid and inhospitable place for human life as we know it. The cold temperatures also mean that any liquid water on the surface quickly freezes, making it difficult to sustain life. To make it habitable, we need to raise the temperature. Scientists and researchers have been exploring various methods to achieve this. The goal is to create a more Earth-like environment where humans can live and thrive. This involves not only warming the planet but also creating a stable atmosphere that can support life. The process of making Mars habitable is known as terraforming, and it is one of the most ambitious projects ever conceived by humanity. It requires a deep understanding of planetary science, engineering, and environmental science. One proposed solution is to use giant orbital mirrors to reflect more sunlight onto the planet's surface, gradually warming it. These mirrors would be placed in orbit around Mars and positioned to direct sunlight to specific areas. The idea is that by increasing the amount of sunlight that reaches the surface, we can raise the temperature and begin to melt the ice caps. This would release water and carbon dioxide, which could help to thicken the atmosphere and further warm the planet. The concept of using mirrors is not new. It has been proposed for other planetary bodies as well. However, the scale of the mirrors needed for Mars would be enormous, and the engineering challenges are significant. Despite these challenges, the potential benefits make it a compelling idea. Another is to release greenhouse gases into the atmosphere, trapping heat and initiating a runaway greenhouse effect. This method involves releasing gases such as carbon dioxide, methane, and water vapor, which are known to trap heat. By increasing the concentration of these gases in the Martian atmosphere, we can create a greenhouse effect similar to what we have on Earth. This would help to raise the temperature and make the planet more hospitable. The challenge here is to find a sustainable source of these gases and to release them in a controlled manner. Some scientists have proposed using factories to produce these gases, while others suggest mining them from the Martian soil. Regardless of the method, the goal is the same: to create a stable and warm environment that can support human life. The combination of these two methods, using mirrors to reflect sunlight and releasing greenhouse gases, could potentially transform Mars into a new home for humanity. The journey to make Mars habitable is long and complex, but the rewards could be immense. Water is crucial for life as we know it, a fundamental element that sustains all living organisms on Earth. It is involved in every aspect of our daily lives, from the water we drink to the food we grow, and even the air we breathe. Without water, life as we know it would not exist. And while Mars has polar ice caps, these frozen reservoirs hold the key to unlocking the red planet's potential for supporting human life. The ice caps are composed primarily of water ice, mixed with some dry ice or frozen carbon dioxide. These ice formations are a testament to Mars's climatic history and its potential to harbor life, and evidence of past liquid water, which suggests that Mars once had a much warmer and wetter climate. Ancient riverbeds and dried-up water channels crisscross the Martian landscape, hinting at a time when liquid water flowed freely on the surface. This evidence fuels our curiosity and drives our quest to uncover the secrets of Mars' watery past. Accessing and utilizing it is vital. Future missions to Mars will need to develop innovative technologies to tap into these water sources. Astronauts and rovers will work tirelessly to drill into the ice caps and extract the precious water hidden beneath the surface. This endeavor is not just about survival, it's about thriving on a new world. Melting the ice caps could release trapped water, providing a steady supply for human consumption and agricultural needs. Scientists are exploring various methods to melt the ice, from using solar mirrors to harnessing the power of nuclear reactors. Each approach has its challenges, but the potential rewards are immense. While extracting water from hydrated minerals in the soil is another possibility. Mars's soil contains minerals that have water molecules bound within their structure. By heating these minerals, we can release the water and collect it for use. This method could complement the extraction of water from ice, providing a more diverse and reliable water supply. This water could be used for drinking, irrigation, and supporting plant growth in Martian greenhouses. Growing food on Mars will be essential for long-term missions, reducing the need for resupply missions from Earth. Fresh water will enable astronauts to cultivate crops, ensuring a sustainable food source and improving their quality of life, and even generating oxygen through electrolysis. By splitting water molecules into hydrogen and oxygen, we can produce breathable air for habitats and fuel for rockets. This process is a cornerstone of in situ resource utilization, allowing us to live off the land and reduce our dependence on Earth. Unlocking Mars's water resources is not just a scientific challenge, it's a crucial step towards making humanity a multi-planetary species. The Martian soil, or regolith, lacks the nutrients necessary for Earth-based plants to thrive. To cultivate crops, we'll need to enrich the soil, potentially using Martian bacteria or genetically modified organisms. Creating enclosed, controlled environments like greenhouses could offer a more immediate solution for growing food. Seeking shelter underground, shielding humanity from radiation. Mars's thin atmosphere provides minimal protection from harmful radiation from the sun and cosmic rays. Building habitats underground or within natural caves could shield inhabitants from radiation. Developing radiation-resistant materials for construction and spacesuits is also crucial for long-term survival. A mirror to ourselves. Lessons from terraforming Mars. The challenges of terraforming Mars offer valuable lessons for addressing environmental problems on Earth. Developing technologies to manage atmospheres, conserve water, and create sustainable ecosystems could have direct applications on our own planet, helping us combat climate change and resource depletion. Beyond the horizon, a future among the stars. Successfully terraforming Mars would represent a pivotal moment in human history, demonstrating our ability to inhabit other worlds and ensuring the long-term survival of our species. It would pave the way for further exploration and colonization of our solar system and beyond. Are we ready? As humanity stands on the brink of a new era, the prospect of interplanetary life beckons us with both excitement and trepidation. The idea of living on another planet, particularly Mars, has captured our collective imagination for decades. But are we truly prepared for the monumental challenges and responsibilities that come with such a leap? The challenges and responsibilities of interplanetary life. Establishing a human presence on Mars is not just a technical challenge, it is a profound test of our ethical, social, and environmental values. The logistics of sending humans to Mars, building habitats, and ensuring their survival are daunting enough. But beyond the technical hurdles lie deeper questions that we must address. While the dream of living on Mars is alluring, it comes with significant ethical and philosophical implications. The Martian landscape, untouched and pristine, presents a blank canvas. But should we, as stewards of Earth, impose our will on another planet? The act of terraforming or altering Mars' environment to make it more Earth-like raises critical questions about our right to change another world. It's crucial to consider the ethical and philosophical implications. What are the moral responsibilities of colonizing another planet? How do we ensure that our actions do not lead to unintended consequences, both for Mars and for Earth? Philosophers and ethicists are already debating these issues, but as we move closer to making interplanetary life a reality, these discussions must become more urgent and inclusive. Should we terraform another planet, potentially altering its environment irreversibly? The process of terraforming could take centuries and would require massive resources. It could also have unforeseen impacts on any potential Martian ecosystems. Are we prepared to take on such a responsibility, knowing that our actions could have irreversible consequences, potentially altering its environment irreversibly? The ethical considerations of terraforming are complex. On one hand, it could provide a new home for humanity and a backup plan in case of catastrophic events on Earth. On the other hand, it could mean the loss of Mars's natural state forever. Scientists and environmentalists are grappling with these dilemmas, weighing the potential benefits against the moral costs. Who gets to decide who goes to Mars and what kind of society we build there? The selection process for Mars colonists will be fraught with ethical and social challenges. Who has the right to be among the first settlers? How do we ensure diversity and representation in this new society? These decisions will shape the future of interplanetary life and reflect our values as a species. And what kind of society we build there? The social structure of a Mars colony will be a microcosm of human civilization. Will we replicate the systems and hierarchies of Earth? Or will we take this opportunity to create a more equitable and just society? The choices we make will have lasting implications for the future of humanity in space. These are questions we must grapple with as we venture further into the cosmos. The journey to Mars is not just a physical expedition, it is a journey of the human spirit. It challenges us to think deeply about our place in the universe and our responsibilities to each other and to the planets we may one day call home. As we venture further into the cosmos, we must carry with us the lessons learned on Earth. The challenges of interplanetary life are immense, but so are the opportunities. By approaching these challenges with wisdom, compassion, and foresight, we can ensure that our journey to the stars is a testament to the best of humanity. Our home, Earth, is a vibrant oasis, a unique gem in the vastness of space. It is a planet teeming with life, from the deepest oceans to the highest mountains, a delicate balance of ecosystems that sustain us. In the vast cosmic desert, amidst the infinite expanse of the universe, Earth stands out as a beacon of life, a rare and precious cradle of existence. Yet we humans are pushing its boundaries. Pollution chokes our skies, filling the air with toxins that harm both nature and ourselves. Our relentless industrial activities have led to smog-filled cities where the air we breathe is no longer pure. Temperatures rise, threatening our very existence. The ice caps are melting at an alarming rate, causing sea levels to rise and weather patterns to become more extreme. Heat waves scorch the land, making it difficult for many species, including humans, to survive. What if Earth becomes uninhabitable? Where will humanity turn? As we face the potential of a desolate future, we must ask ourselves, can we find a new home among the stars? The answer may lie in the stars, in the exploration of distant worlds that could offer us a second chance. On a cold, barren planet we call Mars, this red planet with its rocky terrain and thin atmosphere has long captured our imagination. Mars, our celestial neighbor, holds the promise of a second home for humanity. With its potential for water and resources, it offers a glimmer of hope for a future beyond Earth. It beckons us with the potential for life, a chance to start anew. Scientists have discovered signs that water once flowed on Mars, raising the possibility that life could have existed there, or might still exist in some form. A chance to start anew. Establishing human settlements on Mars would be a monumental step for our species, a bold leap into the unknown. But transforming this alien world into a habitable planet is a challenge of unprecedented scale. Terraforming Mars would require altering its atmosphere, temperature, and landscape to make it suitable for human life. It will require ingenuity, perseverance, and the combined efforts of the brightest minds on Earth. Engineers and scientists are already working tirelessly on the technology needed to make this dream a reality, and a deep understanding of planetary science. The journey to Mars will test our limits, but it also represents the boundless potential of human innovation and our unyielding spirit of exploration. Today, Mars is a harsh and unforgiving world. Its thin atmosphere, composed mostly of carbon dioxide, offers little protection from the sun's radiation. Temperatures plummet to bone-chilling lows, making liquid water a rarity. Dust storms rage across the planet, engulfing everything in their path. Life as we know it cannot exist on Mars. Not yet. But beneath its desolate surface, Mars holds the key ingredients for life: water ice, carbon dioxide, and minerals. These resources, if harnessed correctly, could pave the way for a Martian biosphere. Terraforming, the process of transforming a planet to make it suitable for life, might sound like science fiction. But the science behind it is very real. It involves manipulating a planet's atmosphere, temperature, and surface to mimic the conditions found on Earth. The goal is not to recreate Earth on Mars. It is to create an environment where humans can live and thrive without the need for spacesuits or artificial habitats. Imagine walking on Mars, breathing fresh air, feeling the warmth of the sun on your skin. This is the dream of terraforming. One of the most critical challenges of terraforming Mars is raising its temperature. The red planet, as it is often called, is a cold and barren world, far from the warmth and comfort we experience on Earth. The harsh, frigid environment of Mars presents a significant obstacle for any potential colonization efforts. The planet is frigid, with an average surface temperature of about -63 degrees Celsius, or -81 degrees Fahrenheit. These extreme temperatures make it impossible for liquid water to exist on the surface, which is essential for life as we know it. The cold also poses a threat to any human explorers or settlers, as well as the equipment and habitats they would rely on. To make Mars habitable, we need to warm it up, and one way to do that is by creating a greenhouse effect. This process involves trapping heat from the sun within the planet's atmosphere, much like how a greenhouse on Earth retains warmth to nurture plants. By increasing the temperature, we could potentially create a more Earth-like environment on Mars, making it more suitable for human life. The greenhouse effect occurs when certain gases in the atmosphere trap heat from the sun. These gases, such as carbon dioxide, methane, and water vapor, allow sunlight to enter the atmosphere but prevent some of the heat from escaping back into space. This trapped heat warms the planet's surface, creating a more hospitable environment. On Earth, carbon dioxide is a major greenhouse gas. It is released through natural processes like respiration and volcanic eruptions, as well as human activities such as burning fossil fuels and deforestation. The increase in carbon dioxide levels has been a significant factor in global warming and climate change on our planet. On Mars, we could potentially release trapped carbon dioxide from the polar ice caps and soil. The polar ice caps on Mars contain large amounts of frozen carbon dioxide, also known as dry ice. By heating these ice caps, we could release the carbon dioxide into the atmosphere, increasing its density and enhancing the greenhouse effect. This could thicken the atmosphere and trap more heat, gradually warming the planet. A thicker atmosphere would not only help retain heat but also provide some protection from harmful solar radiation and micrometeorites. Over time, this process could transform Mars into a more temperate and livable world, paving the way for future human exploration and possibly even colonization. Section 5. Oxygen, the breath of life. Warming Mars is just the first step. We also need to create a breathable atmosphere. Earth's atmosphere is about 21% oxygen, a gas essential for human life. On Mars, oxygen is present in trace amounts. To generate oxygen on a planetary scale, we could enlist the help of tiny organisms, algae or cyanobacteria. These microscopic powerhouses use sunlight to convert carbon dioxide into oxygen through photosynthesis. By seeding Martian soil with these organisms, we could slowly begin to transform the Martian atmosphere into one we can breathe. Section 6. Water, the elixir of life on Mars. Water is the lifeblood of any biosphere, and Mars has plenty of it, locked away as ice beneath the surface and in the polar ice caps. The challenge lies in accessing this water and transforming it into a usable form. One proposed method involves using orbital mirrors to focus sunlight on the Martian ice caps, melting the ice and releasing water vapor into the atmosphere. Another idea involves using nuclear power to melt subsurface ice, creating reservoirs of liquid water that could sustain life. Section 7. Martian Soil Toxic Challenge, Potential Solution. The Martian soil presents another hurdle. It contains high levels of perchlorates, toxic chemicals that are harmful to humans. Before we can grow crops on Mars, we need to find a way to remove these toxins. One solution might be bioremediation, using microorganisms to break down the perchlorates into harmless substances. Another possibility is to use phytoremediation, planting specific types of plants that can absorb and neutralize the toxins. Section 8. Beyond Mars, other candidates for terraforming. While Mars is the most promising candidate for terraforming, it's not the only one. Venus, with its thick, hot atmosphere, presents a unique set of challenges and possibilities. Jupiter's moon Europa, with its subsurface ocean, could also harbor life, perhaps even life as we know it. Terraforming these celestial bodies would require even greater technological leaps than terraforming Mars. But the potential rewards, expanding life beyond Earth and ensuring the survival of our species, are simply too great to ignore. Section 9. The Terraforming Dilemma, Challenges and Ethical Considerations. As humanity looks to the stars, the idea of transforming Mars into a habitable world has captured our collective imagination. Terraforming a planet is a monumental undertaking, fraught with challenges and ethical dilemmas. The sheer scale of the project is almost beyond comprehension, requiring advancements in technology and unprecedented levels of cooperation. The energy required would be immense. We would need to harness and generate power on a scale never before seen, possibly through solar panels, nuclear reactors, or even fusion power plants. The technology needed is still in its infancy. While we have made significant strides in robotics and artificial intelligence, the tools and machines required to terraform an entire planet are still years, if not decades, away from being realized. And the ethical implications of altering another planet to suit our needs are profound. We must consider the potential consequences of introducing Earth-based life forms to Mars, and the impact this could have on any existing Martian ecosystems, no matter how primitive they might be. Some argue that we should focus our resources on fixing the problems we've created on Earth instead of trying to escape them. They believe that our priority should be to heal our own planet, addressing issues like climate change, pollution, and biodiversity loss. Others believe that terraforming is essential for the long-term survival of humanity. They argue that expanding to other planets is a necessary step to ensure our species' survival in the face of potential global catastrophes, such as asteroid impacts or nuclear war. The debate is likely to continue for decades to come. As we advance our technology and deepen our understanding of both Earth and Mars, the arguments for and against terraforming will evolve, influenced by new discoveries and changing societal values. The dream of terraforming Mars is a testament to human ingenuity and our unyielding desire to explore the cosmos. It represents our drive to push boundaries and to seek out new frontiers, even in the face of seemingly insurmountable challenges. It is a reminder that we are not bound by the limits of our planet, that our future may lie among the stars. As we look to the heavens, we are inspired to dream bigger, to imagine a future where humanity thrives on multiple worlds, united by our shared quest for knowledge and exploration.